Hi, Assalamualaikum. Today we are going to present our Calculus 1 Assessment 2 Technique of Differentiation. And this slide was prepared by CS112A Group 2 for Miss Nur Fatihah binti Harun. So this is our group members. My name is Syafiqah Liana binti Muhammad Syarizan.
My name is Intan Nur Izani binti Saiful Azmi.
My name is Idina Hanania binti Muhammad Hafiz.
My name is Alia Tika binti Zamsuri.
Okay, so here is the plan for our presentation today. First, we will give a short introduction to differentiation. Next, we will show our problem mind map. Then we will explain step-by-step solution for all our questions. Finally, we will share our conclusion and references.
Okay, what is differentiation? Differentiation is a process where we find the derivative of a function. Moreover, differentiation also a process to find the instantaneous rate of change in function based on one of its variable.
Okay, this is the mind map of our question. So, problem solution for question 1. Explain the concept of differentiation and briefly describe the technique of differentiation. Differentiation is a mathematical process in mathematics that used to find the rate of change of a function. In other words, differentiation tells us how fast something is changing at any point. The derivatives are all about finding the slope. Based on Calculus 1 revision guidebook, the derivative of a function at a specific point is equal to the slope of the tangent to the graph at that point. And technique of differentiation are product rule, quotient rule, chain rule, constant rule, power rule, sum and difference rule, and also constant multiple rule. Now let us look at the question 2a. In this question, we need to find the derivative for the function. First, we simplify the equation by rewriting the cube root as a fractional power. We change the first part into the exponent to the power of 2 over 3x. Because these two different parts are multiplied together, we must use the product rule to solve it. We split the function into two parts, labeling the exponential part as u and the cosine part as v. We differentiate each part separately. When we differentiate the cosine part, v, we have to use the chain rule because there is another function inside it. This gives us negative sign multiplied by the derivative of the inside bracket, which is negative 8x cubed. Finally, we put our derivative back into the product rule formula and factor out the common terms to get the final answer.
Now I will explain question 2b. The question asks us to find the derivative of this function, which is hx equal to ln cot 2x plus 1 over 1 minus x squared. First, we use the logarithm quotient rule as shown at the top. So we change the fraction into subtraction. Um, by applying this formula, we got hash x equal to ln cot 2x plus 1 minus ln 1 minus x squared. Next, we differentiate using the chain rule. And then we combine everything together, and as you can see, h prime x minus 2 cosec squared 2x plus 1 over cot 2x plus 1 minus 2x over 1 minus x squared. We when minus and minus, it will become plus. So our final answer is h prime x equal to negative 2 cosec squared 2x plus 1 over cot 2x plus 1 plus 2x over 1 minus s squared.
I will explain for question 3. Given 2 cosec x plus y minus ln e power 2y equal 4x square plus xy. Find dy over dx using implicit differentiation. For answer 3, we need to separate into 4 parts, which is a minus b equals c plus d. For let a, 2 cosec x plus y, we use a chain rule because it contains x plus y. After differentiate, we get negative 2 cosec x plus y, cot x plus y, 1 plus dy over dx. Next, for let b, ln e power 2y, we simplify it into 2y then the derivative becomes 2 dy over dx. For let's see equal 4x squared, we use a power rule and get 8x. Let d equal xy, we use a product rule. The formula is uv prime plus vu prime. Let u equal to x, u prime equal 1, v equal y, v prime equal dy over dx. So the derivative is x dy over dx plus y. After differentiate all part, we combine them together. Then we collect all terms with dy over dx on the left side and terms without dy over dx we goes on the right side. Finally, we make dy over dx the subject to get the final answer.
Okay, now we will move to the question 4. Question 4 asks us to use linear approximation to estimate the value of cosine 3 pi over 4 minus 0.01, correct to 4 decimal places. So to solve this question, we will be using the linear approximation formula to find the estimate value of this cosine function without evaluating it directly. Okay. First of all, we have to identify the given value, chosen value, changes of x, and function x cosine to substitute the value inside the formula. Okay. And then for the second step, we have to find the derivative of our function, which is f prime x as well as f prime x naught. Okay. And last but not least, we will use the linear approximation formula to get our final answer. Okay, we have to substitute all of our value inside this formula to get our final answer. Our final answer in radian and also must meet must correct to 4 decimal places.
From this project, we can conclude that it helped us understand differentiation clearly as it clarified the core technique that we learned in class like power rule, product rule, and chain rule. Moreover, we also apply implicit differentiation. Besides that, this knowledge and skill are highly applicable in economy and statistics. For example, we apply differentiation in marginal concept. Other than that, we also use differentiation in elasticity of demand to measure the sensitivity of the quantity demanded of a product toward the change in its price. That's all from us. Thank you.